Great. Hey, everyone. I'm Jerry, co-founder, CEO of LlamaIndex. For those of you who don't know, LlamaIndex is a company that gives developers the tools and infrastructure to build LLM-powered applications over your enterprise data. And so the topic of this talk will be on building an advanced knowledge assistant. How many of you know what RAG is? Should be like 99%. All right. How many of you are building agents these days? All right, yeah, so a good amount of you. And I think this is basically a bridge between, kind of data indexing, retrieval, all the best techniques there, along with emerging agentic architectures on how do you actually combine the two to build something that's, again, like an advanced knowledge assistant over your data. So let's get started. The agenda will basically be, the 5 main parts. First, we'll give an overview of just like why naive RAG sucks, and then afterwards we'll talk about how to make it better. So how do you make it better? You want to do high-quality data and retrieval. This includes, we've had integrations with Anyscale and Ray. They're great partners, and basically, we've had tutorials on how do you use Ray, for instance, to speed up like document ingestion. We'll talk about agentic reasoning over complex inputs. We also have LLM integrations and embedding integrations with Anyscale. So if you're using the Anyscale platform, you can deploy like an open weight LLM, fine-tune it, and use it for agents. And then 4, agentic decision making and output generation. How do you go beyond like a standard chatbot response? And then 5, deploying like a full stack application. So the overall definition of what I call like a knowledge assistant is you want to basically build some interface that can take in some task as input and give back an output. A standard RAG chatbot basically takes in, simple questions as input and gives you back like simple answers. But there's a lot more that you can do over your data. Imagine some like universal interface that can literally plug into all the wealth of organizational knowledge within your company, and also index information about you personally, and then can take in basically any task of arbitrary complexity, and then not only give you back like a response, but actually, do everything downstream, produce outputs, synthesize actions for you, do everything. And so that really is the goal of this like, universal knowledge assistant. And we'll talk a little bit about what are some of the steps towards building that, what are some of the recent advances, and then, what's still to come. So, like basic RAG, the basic RAG stack tends to not really be the full architecture that you want to implement, right? It's just an initial start. And there's a lot of issues if you try to just implement a RAG assistant and expect it to basically solve all the issues for you in terms of knowledge synthesis within the enterprise. The basic RAG stack basically consists of, you load in some data, do some, naive like chunking based on the number of tokens, put it into some vector store, do some basic retrieval, like top K retrieval from the vector store, and then, stuff it into an LLM to synthesize an answer. There's a lot of RAG resources out there, but really RAG is just an initial technique and doesn't really leverage a lot of kind of more advanced components to both give you higher quality responses and tackle more complex inputs. One, there's no query planning or a general understanding layer in the front using an LLM. The standard RAG stack basically just uses an LLM to synthesize information, but doesn't actually use it for decision making. So there's no function calling or tool use, and it's also typically like a stateless service. It takes in some input and it gives back an output. And one of the issues that a lot of enterprise developers run into is basically in productionizing agents or just different types of LLM applications over your data. It's typically pretty easy to follow like a tutorial and build a simple prototype over like 1 or 2 documents. It typically becomes a little bit harder, and this is where the bulk of a lot of developer time is spent in the enterprise, is setting up, productionizing some of these data and agent pipelines, and then actually maintaining it in production. And so the quality bar is higher. You have to demonstrate that you have better performance over the broad set of user questions. And some of the top pain points that we've hear developers bring up is accuracy issues. It's not quite giving you back the response quality that you expect. You're spending a lot of time tuning and iterating upon the system. It's hard to secure, so basically, actually connecting to like Microsoft SharePoint, indexing all the access control lists, and somehow feeding that into your LLM application is actually a big challenge. And then sometimes it takes you like a few months to build out that first Gen AI use case in production internally, but you obviously don't want to take like another 5 months to build out like a second use case. So how do you actually centralize, some of the best practices and, like build some overall platform for your other developers to iterate more rapidly upon like more use cases? So a lot of our focus as a company is really enabling you as the enterprise developer to build proper production-ready knowledge assistance rapidly over your data. And ideally, it goes beyond just what, kind of like the standard RAG chatbot that you can spin up in minutes does. Ideally, we help you solve issues around like hallucinations, issues where you're not actually adding that much value to the end user, and it's not really, helping to automate a ton of decision making for your stakeholders. So the 4 main pieces of a better knowledge assistant, we think, are the following. One is higher quality data and retrieval modules. So this, we think, is just a base layer that basically every LLM stack should have in order to, basically you want to have the right foundation for success, right? No matter what levels of agentic reasoning you layer on top. The second is adding some layer of just agentic architectures over your inputs so that you're able to find the right orchestration, to find the right flows, and the right agentic modules to basically compose something that's more sophisticated than directly feeding in the prompt into the vector database. The 3 is generalizing the chatbot response into something that actually automates decision-making a little bit more. So instead of just getting back like a text response, actually producing an entire report, doing data analysis for you, generating a slide deck, and taking actions. For instance, actually calling an API, calling a tool to do something on behalf of the user. And then finally, if we have time, I'll talk a little bit about what it takes to actually deploy this in a production setting and maybe the infrastructure components that you need. First, on high quality data and retrieval. This is basically how we started as a company, and we've basically talked about this in every single talk with iterations, with each talk. But basically, like data is one of the fundamental pieces of a properly functioning LLM application. If you don't have good data quality, you're not going to have a good LLM application. So the garbage in, garbage out principle applies here too. And what we really see is there's this aspect of like data ETL that's basically emerging that converts unstructured data like your PDFs, web pages, basically any source of information that you have into some sort of format that you can then connect to an LLM agent system. At a basic level, if we think about what a RAG is, really half of RAG is that ETL step, loading in like a document, chunking it, indexing it, putting it into a vector database. And that's a reasonable start, but there's stuff that you can basically build on top of this to build something that's a little bit more sophisticated and can lead to higher quality responses. We're especially interested in complex documents. We've been interested in this problem space for at least over a year. And as we worked with different companies and users on different types of use cases, a lot of knowledge out there, especially within the company, is locked up in PDFs, PowerPoints, Excel sheets, and more. And so a lot of these documents are more formatted for human consumption than machine consumption. This is why like PDF parsers are a thing. But a lot of these documents have tables, charts, images, like weird fonts, headers, footers, and a lot of different edge cases here. And users want to somehow trust that a system can just swallow all these documents, all this information, no matter the quantity. And somehow, the ideal is to just like connect your LLM to like a million PDFs and have it properly answer questions over that. And so building something that's production ready over this data is challenging. And I wouldn't say we've solved this in a very general sense, as in like there's a like incredibly general architecture that works across literally every single use case. But we have certainly solved this for some of our both customers and also users on a more domain-specific setting. The first piece is parsing. Most document parsing is inadequate. It's surprising how much parser actually affects your performance. If you parse like an Excel spreadsheet, or you parse like a slide deck with a bunch of images and tables, like if you use PyPDF, it's going to extract it oftentimes in a really bad format. Fortunately, like OpenAI models and other LLMs are actually, I'm pretty sure, trained on like PyPDF outputs. But nevertheless, if you just directly use a PDF parser and try to stuff the parse context into the LLM, it's basically ripe for hallucinations. The reason is that these parsers basically aren't amazing at parsing out like complex entities, and so they will jumble the text and numbers within the page and basically confuse the LLM as to what is exactly the right source of information that I should be following. And so the first thing that we wanted to build was an LLM native document parser. An ideal GenAI native parser can structure complex document data for any downstream use case. If we imagine like a PDF research report with a lot of images, tables, and figures, we can basically first split it off into the constituent elements. So we have like the text. Somehow we are able to parse out like the tables, the diagrams, semantically preserve them, right? So we don't like split tables down the middle. And then once we actually create this overall like document graph of sorts, then we need to figure out a way to somehow extract out relevant information from the visual elements on the page. If you have charts or images, and you want to use text embeddings for indexing, ideally you have some sort of extraction layer that can properly, caption these charts and images into some, text node that you can store in a vector database. So something that is LLM native should be very good at extracting out the relevant kind of entities within a document and then representing them in a way that's suitable for both retrieval and then also for synthesis using an LLM. The non-requirements for such a document parser include actually needing like a very structured metadata for every element. Because the end goal here really is to just like structure the text appropriately so that you can feed it into a language model. You don't necessarily need all the metadata that comes if you were to use like an off-the-shelf document parser, by AWS, Azure, and so on and so forth. And so that's really what we set out to build. And one of the first things we built was this service called LlamaParse, which if you guys haven't checked it out, some of you might be using it, is like a publicly available API that basically is actually designed specifically for LLM application or application development. And so it's both GenAI native, it uses models under the hood, and it's really, really good at parsing out these PDFs or documents, or just, we support like dozens of different document types with a lot of these complex elements and structuring it the right way. So good parsing itself is, one of the main ingredients for your LLM application. Even without any sort of advanced indexing retrieval, having good parsing will help to reduce hallucinations in your application. So this is just, I'll kind of like gloss over this example, but it's basically within our repo as well. We parse a variety of different types of documents. In this example, it's like a train table. In some other examples, it includes, again, these like legal contracts, like tax forms, like a variety of different forms of data where there's a lot of like heavy visual elements and spatial elements on the page. And we basically just show, by laying it out in some neat, like structured manner, LLMs have a much better time understanding it than if you just use like PyPDF and everything's kind of collapsed on top of each other. A basic experiment I did actually is with OpenAI 01, right, which just released like a few weeks ago and is now available to everybody. If you just format like a spreadsheet, like a big spreadsheet, an Excel file, into something like this, into a markdown format that roughly structures the table like this, and then you just like dump this text into the prompt of 01, it's actually surprisingly good at basically just understanding the entire spreadsheet. And there's certain advantages in just like being able to dump formatted text into the prompt like that. You can then combine, of course, parsing. The advantage of having like these cohesive like text, table, and image elements from the parser is you can then leverage fancier indexing retrieval algorithms to then better like fetch the right information during the retrieval process. Retrieval is obviously one of the second main pieces of RAG, and by parsing out the document into text, tables, and images, you can then do some sort of like hierarchical indexing retrieval to make sure that you have a set of like representations that all link to the same underlying source representation. So the three-step process is you leverage your parser, parse stuff into different elements, and then for each element, extract a few different types of text representations that can be indexed, and then have every single one of these text representations point to the underlying source representation. These nodes in the middle layer, the text representations, are the things you're going to put into your vector database and store along with any sort of structured metadata. But when you feed stuff into the language model, basically you retrieve from the nodes and then you link back to the source elements. And especially with multimodal models, you can directly stuff both the text and the images into the model itself. This is an example of something that's a little bit more advanced in like a multimodal RAG architecture. Some other advancements recently include just directly embedding or having a joint text and image embedding of the image and text, so that instead of needing to extract out like a text representation, you can index the image directly. And another piece I didn't talk about within these slides is the importance of like metadata extraction. So, instead of just having like a text chunk that's not grounded in the overall global context, like Anthropic, for instance, just came out with the contextual retrieval blog post, which we just put out a notebook on. But basically, the idea is that for each text chunk, or every chunk in general within the document, feed it into an LLM along with the entire document text and ask the LLM to basically explain how the chunk fits in the context of the entire document. Adding that type of metadata basically adds grounding and basically allows the model, both the retrieval and LLM models, to better understand where that content is relevant relative to the rest of the page. So these are all kind of advanced indexing algorithms, and the better you make your parsing, the better you can basically make use of these algorithms for better results. And then the last piece is just using Ray to I think we did this collaboration actually about a few months ago or a year ago, but we have some example resources where given some set of files, you can leverage our open source library, combine it with Ray, and basically take advantage of very fast distributed data loading, parsing, and embedding. Oftentimes, if you try to index, 1,000 to a million PDFs, it can be quite slow. And so this is actually a pretty simple way to basically just get up and running, and you can get started on your local computer. The last thing I'll say on this front is LlamaCloud, which is our overall managed enterprise RAG platform to help connect your unstructured enterprise data to your LLM agents. It's basically our enterprise RAG platform that captures a lot of these end-to-end processes of parsing, indexing, and retrieval. So if you didn't want to build a lot of this yourself and really just wanted kind of like an overall service to help index your data in a way that's also enterprise ready, come talk to us, and I'll drop the link at the very end of this. The next section is on agentic reasoning. So we have a good data foundation, and then let's actually layer on some aspects of agents on top of this. First, naive RAG works well for pointed questions, but fails on maybe more complex tasks. So this includes summarization questions, comparison questions, multi-part questions, and research tasks. The reason is a standard RAG pipeline will do top K retrieval and fetch relevant context from a specific piece of your document corpus. But for some of these questions, you either need multi-turn retrieval. For instance, for a multi-part or comparison questions, you might want to do chain of thought to break down the question into sub-questions. Or for summarization questions, you might need the entire document as context instead of just specific pieces. And so how do we, the issue is if you just use the standard RAG architecture, it doesn't really account for this need for almost dynamic retrieval depending on the content of the question. And this is where some aspects of agentic reasoning start becoming useful. We basically make a distinction between agent ingredients, which are specific pieces of agents of what we call agentic. They can plug into your overall application. And then basically full, more general agent architectures like React, LLM compiler, a lot of like tree of thought, a lot of like full agent systems that can act autonomously given some set of tools. They have trade-offs. So if you just use agent ingredients, like just use some simple components, it's going to be less expressive, but might be more reliable because you can actually directly control how you're using these components and can lead to lower cost and latency. And especially for more full-blown agent architectures, they tend to be a lot more expensive. And oftentimes, if you try to ask them to do like very general tasks, they go off the rails. However, there is a promise in just in simplicity and just being able to plug in a set of tools into some general agent and asking it to do whatever the basically a bunch of different things for you as opposed to a specific set of things. And we see agents as basically a layer. If you think about like what's the relationship between RAG and agents, basically like every data interface in the world of agents is just a tool. So for an agent, a vector database, a SQL database, web search, they're all just tools that you can plug in to some sort of like agent, whether it's simple and constrained or unconstrained, as some interface that LLM can call. And so for a vector database, maybe the difference with a standard RAG architecture is that instead of just directly feeding in the input into the vector database, first passing it to an agent reasoning layer that's capable of tool use so that it can decide, first, do I want to call this vector database? And two, what are the parameters I should call this vector database with? Again, there's different components you can plug into this agent reasoning layer, like the tools that you want to use, whether you want to use like a reflection layer, whether you do some sort of like more sophisticated query planning, and whether you maintain state. But there's also very custom architectures that you can build yourselves too, and are supported within some of our abstractions. And so along those lines, and this is related to this idea of building something that's more simple and constrained versus building something that's unconstrained. There's advantages to both. Some folks, especially within customer supports or within specific use cases where there's a lot of like human constraints you want to define, are like some of these programs basically just look like general Python programs with some LLM calls in the middle, right? And so here, for instance, if you have a task and it goes to a single LLM call, like a router that just decides what's the downstream tool that I want to use, then it will just make that decision, call the tool. The tool is just like some other program that executes. Maybe you add like a reflection layer to then validate whether the results are correct, and you get back a response. So what I call more constrained is something with where the human actually defines the flow, or generally defines the overall flow of the program, and the LLM is not like a significant proportion of that overall program and influencing like the control flow. This tends to lead to more reliable outputs. However, again, it has the trade-off of being less expressive. There is, of course, the kind of like simplicity and beauty of like a general agent architecture, where instead of like the human, like you as a developer having to write code and explicitly defining, step B follow step A, here we're basically saying, let's just have this overall, machine. It is capable of reasoning. Like if you think about the OpenAI Assistance API, it's basically this, where you can implement it yourself very easily. You plug in some set of tools into this overall agent, and instead of you saying what the decision making should be for a given task, you just let the agent figure it out. Like in the extreme, you could imagine feeding in like an agent, like 100 to 1,000 different tools, and basically given some task, having that agent break it down into sub-steps and dynamically reason about what is the pathway that I need to take to basically solve the problem at hand. There is something very nice and simple about this. Practically speaking, in most implementations, this is a lot more expensive and can be less reliable. So if you plug in like a React loop or some more fancy agent architecture, there's a good chance that if you don't add additional constraints, that it could get stuck in a loop. It might never complete, and it's going to cause you to use a lot of tokens. And so we want to both build for today and also build for the future. And we have this framework called LlamaIndex Workflows. Many of you might know us as like a RAG framework, but really we've made like giant investments in agents too. And we think an agent orchestration framework should have the following properties. We want to basically enable you to define agents very simply. Similar to like a Python program, you just write like a Python class with a set of different functions. And so we're basically building like kind of almost like a low-level orchestration framework that's event-driven, allows you to model every agent as a set of steps. These steps can either be LLM calls, regular Python, or some mix of the two. It is flexible, so you can literally write whatever you want in the Python class. And it's very extensible to different types of architectures. So whether it's a loop, the more generic agent architecture, or something that's very constrained with like if-else statements, you can easily define that. And we have some surrounding services where we integrate very well with observability providers, and also are working on some neat tools to help you debug and observe the overall state of your agent. And here's just a shout out to like if you're looking to build agents with LlamaIndex, we have an integration with AnyScale LLMs. So if you're trying to connect to LLM models deployed within the AnyScale platform, where I believe you can like bring your own model and then like host it and also fine tune it, you can use LlamaIndex as an orchestration framework to help you build these types of agentic systems. The third piece is on agentic, output generation, basically. So we have this agent reasoning layer. It's good at processing your input and figuring out what to do with it to solve the task. But then, we think about, instead of just like generating like a text response, how do we actually generate a more sophisticated output? So the goal of this really is to help or we basically want to build the right tooling to help developers solve like different types of tasks. So for instance, generate reports. This is actually one of the top use cases that we hear about from different companies. This includes generating like a PDF, filling in an Excel spreadsheet, filling out like a form or questionnaire, like generating a slide deck. I'm sure some of you might have seen examples of this too. And the idea is really like start taking actions on behalf of the user, as opposed to relying on the user itself to basically copy and paste the chat response and format it into something. I'm sure many of you use like ChatGPT or Claude, right? And so if you are a like consumer user of those, you notice like the chat response actually gives you back either code blocks you can directly copy paste, or in like I use Claude for instance, you can directly copy and paste the markdown and just like treat that as like as a report. And so this is exciting because it basically means like instead of the user having to be in the loop at every single stage, we can increasingly trust agents to just like produce the final unit of output for us. And so we're especially interested in multimodal report generation. Basically, given some bank of data, it could be multimodal in nature, as you see in this like slide right here from like an investor report. How do you actually generate an entire document full of like text, tables, and images? So first, we're pretty good at the parsing piece of parsing text, tables, and images, but now we want to generate a similar report and actually fill out a template. This is something that we've made some really good progress on already. So if you're interested, come talk to us. But it's something that we're continuing to invest in, especially in filling out different document types. Another example, of course, is customer support. One of the top use cases that we see among vertical AI startups basically today. This is something that we have some existing templates for, but we hope to basically improve this over time. But the idea is, instead of just being like a chatbot, actually help both deflect some existing user requests and then also directly help your internal customer support agents be more efficient and have higher user satisfaction. And actually, I think this is a good, I think I'm basically out of time too. So I'll stop at this section. But the high level idea is by combining agentic reasoning or agentic architectures with thinking about how you're going to actually increasingly solve the problem for the end user as opposed to just building a chatbot, this, we think, actually leads to much higher ROI for the end user. And increasingly, as if you're in a company, are thinking about ROI and not just like experimentation with the latest techniques, we do think that betting on these right use cases and having the right components to build these use cases will enable you to provide more value to your end users, both for internal facing and external facing use cases. Of course, you need the right tooling and architecture to actually help this make this happen. And I'll skip this piece for now, but basically, if you're interested, come talk to us. So thank you.